Hi everyone, this is Nick and I'd like to welcome you to a quick demo on how you can leverage NVIDIA's RAPIDS framework within the Cloudera data platform to see massive speed increases in typical machine learning workflows. Throughout this demo, we're going to be working in CDP public cloud, a hybrid data platform which gives us access to as many resources as we may need, including NVIDIA GPUs. To get started, we spooled up a workspace and created a project within Cloudera Machine Learning. If this is your first time seeing Cloudera Machine Learning, you may want to go check out some introductory videos posted in the description below. Going into the project, you'll see that we have uploaded a Python script along with some data folders. In order to interact with our code, we're going to start up a Jupyter Lab session with the RAPIDS runtime. We'll also choose a resource profile that includes 32 gigs of memory and 1 GPU. Now jumping into the code, it's first important to note the libraries that are being imported. You'll see that if the mode is set to CPU, our script imports the standard machine learning libraries many of you have seen, such as pandas, numpy, and sci-kit learn. If the mode is set to GPU, however, we're going to import the related RAPIDS libraries such as cuDF and cuML with the same aliases as we use for the standard libraries. This is important because it means that we don't have to do a large code rewrite to obtain the speed benefits of the RAPIDS libraries. Now, in order to showcase these speed benefits, we're going to pull a few months worth of New York City taxi data, do some computationally heavy transforms to get the total ride distance, and then fit a model to predict the fare. We'll keep tabs on how long each one of these steps takes so that we can compare results between the CPU and GPU based libraries. The first major computational hurdle is going to be computing a distance out of various latitudes and longitudes. To do this, we'll be applying a user-defined function to calculate the Haversine distance, which is notoriously slow in pandas. We do have to apply our functions slightly differently between libraries in this case. After the data transformations are complete, we'll take our resultant dataset and split it out into testing and training sets. Once we have these test and training sets, we'll go ahead and train a linear regression model with the target of predicting the fare amount. Now let's run this on the CPU using the traditional libraries and fast forward a bit to see how long it takes. Overall, the combined process took a little over 12 minutes from start to finish. The largest chunk of time was taken doing the data transforms, which took over 8 minutes to complete. Splitting the model into test and train sets to validate the performance took 55 seconds, while training the final model on the entire dataset took just about a minute. Now let's go ahead and run through these processes using the GPU on the RAPIDS framework. This time around, we don't even have to fast forward to the results. By the time I'm done reading this sentence, the script is already just about finished, taking only 21 seconds from start to finish. Looking at where we saved the most time, you can see that those heavy computational functions for calculating distance only took 646 milliseconds, compared to over 8 minutes on the CPU only. The overall speed improvements from 8 minutes down to 21 seconds represent a 34-fold speed increase, with very minor code changes. This is both thanks to the incredible RAPIDS libraries, as well as the hybrid capabilities of the Cloudera data platform, that let us run this code securely and with the amount and types of resources needed to leverage these massive speed gains. Thanks for watching today. If you found this interesting, don't forget to subscribe to see future videos. If you have any questions, head on over to the Cloudera Community, where there are plenty of other users ready to help answer any questions you may have.